These properties are going to help us in the solving definite integrals. So the first property is uh, some key properties of definite integrals are listed below. Property one is if you change the variable of the integration, the value will not change. If it is variable of f, same function, if you have a variable t, this will not change anything. It's because we are going to resubstitute the variable by the limit. So x will become a, t will also become a and b. So that's why this will be same. The second property is very important, interesting, which will be helping us in many places. If we have an integral from a to b limit dx, if you want to change the direction, it will become change the sign also. This will be still same. Therefore, integral of f of x a to b is equal to minus integral of b to a, same function f of x. Okay, that is because if you substitute after integrating, it is f of a minus f of b minus f of a, whereas the opposite one is f of a minus f of b. It is only changed by the sign because of the direction. That is why when you change the sign, you can change the direction of the integral limits or vice versa. Okay. Yes. So now we have next theorem, our next property. Please pay attention to these properties. So if you want to have a limit, say a to b f of x, and between a and b, if there is a number, if there is another number c, such that they are continuous in these places, then we can split this as a to c f of x dx plus c to b f of x dx. These are all going to be useful for us in solving the definite integrals. Okay, so if there is a number between them. Okay, the last one, if you have integral a to b f of x dx, okay, and that will be always equal to a plus b minus x dx. Okay, that is because you can just substitute that a plus b minus x in terms of t. We end up with, we change the, when the value of the variable changes, limit also changes. So when you put a plus b minus x is equal to t, what happens is when you differentiate, dx becomes dt. Okay, so yeah, so please check all these things. Dx become dt and x becomes a, t becomes b. Okay, when x becomes b, t becomes a. So that is how this is again changed to minus of integral of a to b uh, f of t and dt. So please check these statements clearly. We are going to use it in the next class. Definitely we are going to use it in application of integrals. These properties are very important for us. Okay, and also we are going to solve some other questions in the definite integrals using this. The last one is integral of 0 to a f of x into dx is equal to a to 0 f of a minus t into dt. Okay, so which is also equal to this 0 to a. We can change the direction 0 to a f of a minus t dt. All that is same. Okay, so these values are all same. So try to understand and remember them. Last function, last property. If you have a limit like 0 to 2a, okay, we can split as 0 to a f of x dx plus again 0 to a f of x dx. So we can split that. Okay, so we can also write it like this: 0 to 2 a f of x dx can be written as 0 to a f of x dx plus 0 to a 2a minus x dx. So please try to remember these theorems. Okay, so we have another function, another theorem, which is 0 to 2a f of x dx can be written as 0 to a f of x dx plus 0 to a 2a minus x. It's coming from the previous function. Okay, so I'm just taking a quick review of all these functions. Okay, so now, yes, so if there is a limit with the negative numbers and the positive numbers on the lower and the upper limit, f of x dx can become 2 to root of 0 to a f of x dx if f of x is what? Is an even function. Very good. Okay, so and this will become minus a to a plus 0 to a. In that case, what is even function? That's the next question. So what is even function? Even function is nothing but a function after substituting the negative value, the function is not changing. F of minus x is still f of x. Such a function is called even function. So please go through all these theorems in your textbook. Okay, so and remember these theorems which are going to be useful for us in calculation. Okay, and also it will be helping us in many ways in the next chapter, which is application of integrals, which we have tomorrow. Right, tomorrow evening we'll be having the class on application of integrals. So please go through all the theorems which will be used there. Okay, so now let's come to the summary of the entire chapter. What did we learn? Okay, so I'll show you the mind map of this. Yes. So we did the integration as an antiderivative, right? We did the integration of antiderivative and we understood how to solve them and all the types of functions. This is what we started today. Yesterday in the previous class, we understood methods of integration by substitution and trigonometric functions. We understood. Then these are the standard integrations. Integration by substitution we understood, and integration of some special functions we started today. Right? Do you remember that? Yes. And these are the integrals of the standard values which we learned in the first class, correct? Yes. So please have a look at all this.